Move to the side, okay.
In dealing with our approaches to value, the second one that we're going to deal with, and second just because it comes up that way in the book, is the cost approach. As it turns out, real estate agents will never do this. This is a specialized type of valuation that you probably want to be an appraiser to do. However, we mostly need to be familiar with the vocabulary. I'm going to show you a math question, but the math is not tested on the exam. However, the math actually helps you understand the vocabulary that goes along with it. So I'd like you to look in your workbooks and take a look at the first cost approach math problem that we have. I'll read it as we go. Your client owns a building that is 3,500 square feet. The cost per square foot new is $150. Now, in the cost approach, because we're dealing with unique buildings, we don't have a way of evaluating this. We don't have comps like we did in the sales comparison approach. So what we have to do is look at what the building would be worth if it was new. So what we're going to do is we're going to take the 3,500 square feet and we're going to multiply it by 150 per square foot. And how much is that? $525,000. So basically what we have learned is to build that building at $150 a square foot will cost us $525,000. This is what we refer to as the replacement cost. Replacement cost is one of your vocabulary words. Replacement costs. Okay? Well, that's great, but that building is not new. So let's see what happens next. We're going to depreciate from the value of that building. The building is 25 years old, has a useful life of 75 years, and an effective age of 10 years. Now, I will tell you, in this problem, as we spoke about earlier, the 25 years is actually just put there to kind of catch your attention. It's not going to be relevant for the math. So what we're telling you is that this building has a useful life of 75 years. So what we're going to do is we're going to say, if the building new is worth $525,000, and in 75 years it's going to be worth $0, how much is it losing per year? How much is it depreciating per year? $7,000 per year. $7,000 per year depreciation. And it's just simple straight line depreciation. Now let me go back and remind you, this 75 is what we refer to as the useful life of the building. That's the amount of time that it should have some profitable use. In other words, you use it rather than tearing it down. You can't come up with that number. It'll be given to you in the exam. There's not some standard for buildings, okay? So now that we know it's losing $7,000 a year, is the question starting to make sense to you? Notice in the question it says that this building has an effective age of 10 years. So if it's been depreciating by $7,000 per year for an effective age of 10 years, total depreciation is going to be $70,000. So that's total depreciation. And the definition of effective age is the age that the building appears to be given its upkeep. In other words, someone has obviously kept this building in pretty good shape because the building's actually 25 years, but it has an effective age of 10 years old. We've all seen buildings like that. They could be one block away, they could be a couple of years apart. One of them looks pristine because it's taken well care of. The other one is just dilapidated because of lack of care. Okay? Effective age, the age a building appears to be. Now, do you see where we are? If the building was worth $525 new, well, this building's not new. So what's happened? It has depreciated by $70,000 based on our formula here. Minus 70,000. Looks like it's going to be 455,000. Mm-hmm. This is what we refer to as the depreciated value of the improvement. Value of the improvement. Now, as you're looking at the cost approach, and remember, we're going through all this just simply because we don't have comps to deal with. So we have to figure out a way to evaluate the building. Well, if it was brand new, it'd be worth $525, but this one has depreciated down to $455. What have we not taken into consideration? If you continue reading the question, you'll see we've not taken the land into consideration. So notice the next line says the value of the land under the sales comparison approach is $75,000 without accounting for $15,000 in site upgrades. So that land is really worth not only the $75,000 that it would take to buy it, it's also worth the $15,000 where someone has improved it and put in things like water, sewer, utilities, and things like that. So that piece of property is worth $75,000 for the land, $15,000 for the upgrades of the land, and then don't forget $455,000 for the depreciated value of the improvement, for a total value using the cost approach of, what does that come to, $475,000, $545,000. $545,000. That is the value of that land using the cost approach. Why did we have to go through these steps? We don't have comps for this. So we have to create a way to determine the value. Replacement cost. What would it cost to build it today? Well, it wasn't built today. So let's depreciate it from today based on its effective age. $7,000 per year because the useful life in this one was 75. And then the depreciated value of the improvement plus land costs equals total cost under the cost approach. Again, the math, not hard math, but a lot of it, but you're not tested on the math. This is what you're tested on. Replacement costs, depreciation, effective age, useful life. Please know those terms associated with the cost approach.